Hello everyone, welcome back to another AP Physics 1 Dynamics practice problem. Today we'll be going over question 4 in the MIT AP Physics 1 workbook. That'll be in the description down below for you guys to use to follow along. With that being said, let's go into question 4. It says, when the frictionless system shown above accelerated by an applied force of magnitude, the tension in the string between the block is, then we have our answer choices. So what we can do first off is many people will look at this and say, how am I supposed to find the different forces of force tension when I have two different boxes acting on it? And a quick way to solve this is to just treat these two boxes as one system. So doing that, you would have your Newton's second law, which is fundamental for almost all dynamic questions, is F equals mass times acceleration. And if we take this whole system as one full mass, that would be 1 plus 2, making it a total mass of 3 kilograms. So then we could do F is equal to 3 for the kilograms, and then A is equal to A. And if we treat this as one whole system, that means this block and this block both have the same acceleration. So dividing it by 3 to get A by itself, divided by 3, we get that F over 3 is equal to A, which is the acceleration. Now that we know that the acceleration is equal to F over 3, or force over 3, we can now use this acceleration for either block 1 or block 2. But I'll show you guys how to do it for both blocks. So for example, if we were to take block 1 first, we would have that force is equal to mass times acceleration, Newton's second law. And we would do the mass, which is 1 kilogram. So we'd have mass as 1, and the acceleration is constant in the system as it is in the F equals ma equation. So the acceleration for this box is going to be F over 3. So this would be F over 3. And then this F on the left is just asking us what are the forces acting on the 1 kilogram box. And if we look at the image, we can see the only force acting on the box is going to be the tension force. So since that's the only force, we're going to say T for force tension, or we could also say F subscript T. No matter what, they're both the same thing, just dependent on what you want to do it. Me personally, I like to do FT to say force tension, so I'm going to keep it as force tension. So now I have force tension is equal to 1F over 3. And if we look, what is the question even asking? The question is asking what is the force of magnitude, the tension in the string between the blocks. So it's just asking us what is the force tension in the strings, and we got that it's equal to 1 over 3F, which leads us to choice D. But we can also do this using block 2 as our force. So if we go over here, on this side, we have 2 kg. So we have our Newton's second law, force equals ma. Our m is going to be 2 kilograms. So we're going to have 2. Our acceleration, as we said, is constant in this whole system. Since we took it as a whole system, the acceleration is going to be F over 3. So we're going to have F over 3. And it's going to be equal our F. And our F is just the forces acting on the object. And in this case, we have force F acting on the right, and we have force tension acting in the left. Now here is where your coordinate system matters. You can either choose right to be positive or left to be negative, and whichever one you choose, you have to stay constant with the whole question. Me, I like to do right is positive, so I'm going to keep the right as positive and the left as negative. So doing that, force F is acting in the positive direction this way. So we're going to have it as plus F. And then here we have the tension. The tension is already connected to the left side of the object of the 2 kilogram, so it can't come to the right. It's going to be acting in the left, and we already said left is negative, so it's going to be minus force tension. Okay, now that we have force tension is equal to minus F, we're going to have to get this force tension by itself since we want the tension in the string between the blocks. So doing so, we're going to subtract F, we're going to subtract F. Doing so, we have negative F plus 2/3 F. And negative F is the same as negative 3 over 3 plus 2 over 3 F. And that leads us to negative 1 over 3 F. Now that we have negative force tension is equal to negative 1/3 F, to get this negative off of the force tension, we'll divide by -1, divide by -1, giving us that force tension is equal to 1/3 F, giving us the same answer of choice D both ways. I hope that video was very simple for you guys. If not, please comment down what didn't make sense and what I could elaborate on. And as always, guys, remember to enjoy life.